So we're factoring trinomials. First kind of review is, can anybody tell me what a trinomial is? A three-term polynomial. So we know this is going to have 3 terms to it, right? Most of you have kind of picked up on the format of these. What kind of pattern do we tend to see when there's 3 terms involved? Alex? Like, think back to that descending pattern. So what does it usually look like?
A squared.
I forgot now. It's a strategy.
So we usually end up with something x squared plus something x plus a regular number, right? It's kind of the format that we tend to see a lot of times on these. They go in that descending order. When y'all were doing the division, that kind of allowed us to see when pieces were missing or something had to be canceled out. Well, you will typically see that they label them ax squared plus bx plus c. They just give them letters for the coefficients because there's formulas later on that actually use these 3 letters. So when you see something that's talking about ax squared plus bx plus c, that's what we're discussing. When I say simple trinomials for today, what that means is that the a value is always going to equal a 1 for today. So you're not going to have to mess with the number in the front. It's going to minimize to where we're really only dealing with 2 numbers, the b and the c. So if I ask you to factor a trinomial like x squared plus 17x plus 72. First off, does everybody agree that is a trinomial, and the a value on that trinomial, the very first coefficient, would just be a 1, yes, making it a simple trinomial. Okay, if I ask you to factor this, what do you think, Carter?
Wait, I was going to ask, is like the first one the A and then it goes B and C?
Yeah, that's why I wrote A first and then B and then C.
Wait, is that 17?
Thanks. 17 in the middle.
Oh, I thought it was
17 in the middle, 72. Oh, yeah, no. So, according to how we've learned to factor so far, which is find the greatest common factor, what do all 3 of these have in common?
1.
A 1, right?
Yeah, there's no factor.
So this would be like a good answer for that last quiz question where I asked you to do one, because there is no GCF.
Yeah, I think 17's a prime.
All right? This is why 17 is a prime number.
Knew it.
This is why we've got to learn a completely different method for how to factor these things, okay? So now, like, shift your brain completely away from that. Ignore that for just a second. And factoring is basically the opposite of multiplying, right? So if I ask you to multiply x plus 8 times x plus 9. A binomial times another binomial. How do I... Yeah, I just do the box. Sync is exactly right. And because I'm lazy and I don't want to rewrite anything, Carter and Bailey and Maddie, shh. So I don't want to rewrite anything. I'm going to put x plus 8 on the side and line it up right underneath x plus 9. And I end up with x squared. Y'all keep saying x2. That sounds like x times 2 instead of x squared. Then 9x, 8x, 72. And when I combine like terms, I end up with
6x
x squared.
Plus 17x plus 72.
Hey, we just answered the question that we were just looking for, which is that actually the factors of this are right there, x plus 8 times x plus 9. So what we have to figure out is an easier way to connect. Okay, if I know this and I'm trying to get the 2 factors, how can I break this down? And I think some of you may already see it, but let me give you another example and see if what you're thinking follows a pattern. Sometimes it's dangerous to see one problem and go, this is the pattern that must always work, because it's not the pattern that must always work. So let's try another one. If I ask you to multiply x plus 4
Everything just like added together.
times x minus 7 So again, so that I can lead into factoring, we're going to look at kind of multiplying, because sometimes looking at the reverse helps, right, Cadence and Chloe? Yes. Yes. Multiply these two together. I'm still waiting for Chloe to work out this problem. And you. So I set up my box to multiply these together.
Well, how would we know what to multiply?
That's the question.
7 times
That's
4. Sorry, that's why we've been doing these so much.
so the answer to this one is what, Alex?
The answer to this is x squared minus 3x minus 28.
X squared minus 3x minus, that's a minus, 28. And so again, the question is, what we're going to now be given is you're going to be given the trinomial, and we have to back it up to the two binomials. So we're looking for patterns that would help me. If I had only this, how could I come up with these two pieces, Pink?
Well, if you look at it, the two numbers that are not variables,
Mm-hmm.
you add them and you get the -3, and then you multiply them and you get the -20.
That's why we've been doing
Does that work on this one too?
Yes.
If I add them, it makes a 17, but if I multiply them, I get a 72. It's almost like we've seen this somewhere, and there's a reason that Coach Guess has been training us in this for several weeks. Okay, so if you're confused, give me time, and I will explain it. The first thing I want us to make sure that we know is that two binomial factors, meaning I'm multiplying 2 by 2, create what kind of product? A trinomial product. Nothing makes you sound confident in your answer than when you go, a trinomial? Like, I don't know?
Talk like that.
Oh, okay. Because you're never sure.
No, okay.
So if they give me a trinomial product, what I can typically do is kind of know that I'm going to set up two binomials. So, for example, x squared plus 5x plus 6. I can pretty confidently say that this is going to break into two binomial factors. Because that's kind of the pattern that lots of you have picked up on, even if you haven't really thought about it. A lot of times people will bring me problems and go, okay, I know I messed up on this. And the way that you know is because it didn't follow that trinomial pattern in the answer.
I can't draw this.
So let me ask you a question. If I know it's going to be like 2 terms by 2 terms, what's going to give me this x squared, a plain x squared in the front? See?
No, it's x. I got
X, quit. You want to give me the whole answer.
Yes.
Just wait. So first off, is everybody good with, they're both going to start with just an x and an x because that's going to make a plain x squared in the front. That answers half of your answer right there. Now, Sync, you're so excited. This could backfire, but I don't think it's going to. What do you think the back part is going to be?
3 and 2.
How did you get 3 and 2?
Because 3 plus 2 is 5, and then 3 times 2 is 6.
So there's our pattern. It adds to make the middle,
Oh, it's like the wall.
and it multiplies to make the 6. Maddie's just about 3 minutes behind, but she figured it out.
Wait,
Yeah.
I didn't even know that until that.
So we've been doing this on the warm-ups because Coach Guess is a genius who knows what you need to work on before we get there. So I've been conditioning you to be very, yes, don't question it. Don't say that like a question. You're a genius? No, that's what you should sound confident in. So they add to make the middle. They multiply to make the back. They're both positives, right? So I'm going to put plus and plus. If I wanted to prove that this works, I'd have to find the Post-it notes that I threw away earlier because they weren't helping me. So if I wanted to prove it, I could set up a really quick box and say x plus 3 times x plus 2 and I would get x squared, 2x, 3x, and 6. And when I combine everything together, it makes what I want it to make. Okay? So if you need to check an answer, if you're like, I just don't think that's going to work, you can always multiply them back together to test it. All right? All right, let's do another one. How about x squared plus 12x plus 20? Trinomials break into binomial factors.
I've almost got it.
I got it.
Ow.
The x squared is pretty easy to find out.
Yeah, the x squared is the easy part. Oh, x and x.
Oh, yeah.
The harder part is figuring out the numbers.
Nah. Kidding.
Maddie, what'd you get?
Oh, I know it.
So the first one is x plus 2. And the second one is x plus 6.
Yes, and I love that Maddie made a point to not just say 2 and 10, because 2 times 10 doesn't make this, okay? 2 times 10 does not make the right product. X plus 2 times x plus 10 absolutely does. Okay, so again, the pattern is they add together to make the middle, they multiply to make the back number. And then Carter's exactly right. It's really easy to get the x squared. X times x makes the x squared. That's why these are simple ones, okay? All right.